All right, this is the review for Unit 7 video. Let's start with question number 17. And we start with the expression shown below can be written in the form of the product of x plus 4 with another binomial. Determine what the binomial is, determine that binomial, and show how you write out your answers. So to start with, what we're going to do is look in our expression for that x plus 4, and we see it right here. We have to also see what the remainder is when we factor it out. And we're going to change this addition problem into a multiplication problem. So I see the x plus 4 and I rewrite it, x plus 4. Now, once that x plus 4 is out, I have the remainder, and I'm going to put that in brackets. It's going to be the x minus 2 plus the x plus 7. Notice I use parentheses for everything. Now I'm going to combine what I can inside of the hard brackets to simplify. So drop these parentheses, there's nothing in front. But in this, I drop it too. There's nothing but a 1 in front. If there was a minus sign, I would distribute that. Now combining like terms, I'm going to get 2x and then plus 5. Now it said write it with the product of x plus 4 with another binomial, and that's my final answer. Some people do FOIL after this. That would go back to the original problem and just make it more messy. Let's move on to the next question. Write as a product of two binomials again. Find the like factor. In this case, it's x plus 5 and x plus 5, and then factor it out. Same idea, so I'm going to write x plus 5 over here, and then write what I have left, which is 2x plus 11 minus, I'm going to put hard brackets over here, minus x plus 5, x minus 2, because I factored out the x plus 5. So I still have the x plus 5 binomial out front. Now what I have remaining are these terms, which I'll combine after I distribute and drop the parentheses. So I'm going to drop the parentheses because there's nothing in front of it, but here I have a negative in front. That causes this positive x to be negative x and that negative 2 to become positive 2. I combine like terms, and 2x and negative x is x, 11 and 2 is 13. And this is the product of two binomial. That's what we were looking for. Completely factor each of these. So with these problems, you're going to have to look for the method we did during class. So you're going to look for a common factor, and the GCF is going to be equal to a number that goes into all of them, and that's 5. And we end up with 5x squared minus 4x minus 21. Now how I got that was I divided each term by 5, and the remainders are listed in the trinomial. Then we factor this trinomial into two separate factors, and it factors, we ask ourselves what numbers multiply to be 21 that add to negative 4. They have to be, first of all, x and x. They have different signs because the last term is negative, and it's going to be minus 7 and plus 3. So it's best for you to pause probably after each step and then try it yourself. So find the GCF. This time 3x is found in both terms. So I divide both sides by 3x, and I end up with 3x with parentheses x squared minus 25. This one's hard because I want you to recognize that this is a dots. This is the difference of two squares. So we're going to have 3x, x minus 5, and x plus 5. And this is completely factored. There's no more common factors. This one is a little harder. You have to recognize that x to the 4th is nothing more than x squared squared, if that makes sense. So when we ask ourselves, we'll get there, but when we ask ourselves what's x to the fourth, think of it as x squared sometimes. That will help us. Now, I'm going to go back. Hope that didn't confuse you. I'll come back to that, but just I want you to see this as what two things multiply to be x to the fourth, x squared and x squared. That's the key idea. And then numbers that multiply to be 36, this tells us the signs will be the same and they'll both be negative. Numbers that multiply to be 36 that add to 13 are 4 and 9. When we have this, I need you to recognize both of these are dots. This is a dots, and this is also a difference of two squares. So we factor this as the root plus root, root minus root. Over here, it's root minus root, root plus root. Either way, as long as you're subtracting and adding the roots alternatively, you're going to get the right answer. And this is the correct answer right here. Okay, moving on. This one is going to be a common factor of 2. So we take out that GCF, and we're left with 4x squared minus 5x minus 6. Then we factor that the best we can, which is 4x plus 3. We know this will be x. The last term will be minus 2. All right, let's move on to page 2. Small rectangle centered. I'll let you go ahead and read it and write it. I'll get right into the solution. Determine the area of a larger rectangle and versus a small area. So we know we're going to have the area of the large, and we're going to equal length times width. And we want it as a trinomial. So the larger rectangle is going to be 2x plus 7 times x plus 3. That's the length times the width. And that equals, using FOIL, 2x squared plus 6x plus 7x plus 21. And then we combine like terms to be 2x squared plus 13x plus 21. Determine area of the smaller rectangle. Same idea. It's x plus 3 times x minus 5. If you need a little FOIL review, or you can use the area model, but FOIL is the first, the outer, the inner, and the last. So what it looks like when we solve the problem is the first terms, x times x is x squared. The outer is negative 5x. The inner is positive 3x. And the last is negative 15. And then we combine like terms to be minus 2x in the middle term, minus 15. Find the area of the shaded region. You're going to have to subtract the larger from the smaller. Or excuse me, yeah, the smaller from the larger. So we take the larger rectangle, which was 2x squared plus 13x plus 21, minus, I use parentheses now, it's very important, minus 2x minus 15. When we have that, we're going to have to distribute this negative, and we're going to end up with 2x squared plus 13x plus 21, our first term, and then we're going to have minus x squared plus 2x, and the last term is positive 15. And then I'll need to combine like terms wherever I see them. So 2x squared and negative x squared, 13x and 2x, and this will simplify to x squared plus 15x plus 36. Can you give the shaded region in terms of a product of two binomials, x plus 3 and another one? So we write down what we had as a trinomial, x squared plus 15x plus 36, and factor it, but we already have a clue. One of the terms are x plus 3. So what times 3 is equal to 36? That will help us. 12. So we have that term, and that's the answer. Simplify the expression below and write it in standard polynomial form. So there's a couple ways to do it, but the most important thing is you look for any ways you can factor out anything. No. So in this case, we're just going to have to do FOIL to both sides. So the first term will become 3x squared after we do FOIL, minus 10x minus 8. It's subtraction, and then we're going to have to subtract two terms, which is going to FOIL this side, x plus 5 and x minus 1, to be x squared minus x plus 5x minus 5. And when we finally simplify the right side, it's going to be x squared plus 4x minus 5. And then when we subtract them, we distribute that negative to be 3x squared minus 10x, oh, there's a 10x, minus 8 minus x squared minus 4x plus 5, after distributing the negative, to finally get, once we combine like terms, 2x squared minus 14x minus 3. All right.